We'll also be in this for 1 minute warning. Thank you so much. Okay. I think we're ready for everyone. So, it's a start when I start talking. Awesome, thank you. Okay. Good day, everyone. Welcome to the ESP Design Showcase. We are T178, and today we present you the electric wheelchair seat or sled attachment. We'll be talking about how we define a problem, how we define a successful solution to the problem, and how our design best meets that solution. I'm Don Hanna.
What's that? This? I'm Justin Hank.
I'm Queenie Shen.
I'm Hayden Liu.
And I'm Katie Bushel. Now, as a disclaimer, we are a group of first-year students, and therefore this project, as well as the slides and its content, should not be replicated in any shape or form without this disclaimer present.
Alright, so I'm sure by now we're all familiar with the climate in the city of Toronto, especially the winter. We tend to have a lot of snow here, and overall it leaves our infrastructure looking a lot like those pictures on screen. And for most of us, it's not a big issue. It's more of minor inconvenience, there's ice-slip hazards and there's snow inclines, and yeah, they're there, but for most of us, we can sort of just adjust how we walk, so walk around it. But imagine trying to overcome those scenarios if you're using an electric wheelchair. This is the Growing Wheel F5, our client's electric wheelchair, and for me, it works pretty well over the summer months, but during the winter when there is snow and ice, so it does very quickly lose its traction, causing issues such as slips, stalls, and the worst scenarios, even sitting out of control. And those issues are only exacerbated when trying to go over a hilly, inclined terrain, such as that picture. Such as that picture right there. So even though most people are able to enjoy the sort of winter months in these parks like this, for someone who uses an electric wheelchair, this is impossible. And to try to illustrate the problem, there's a video here demonstrating an electric wheelchair user trying to go onto the sidewalk during a snowy time, and you can see how right about there the vehicle stalls and it's no longer able to move, which is exactly the same problem that our client has.
Shown on screen is the Exact 40. While it is able to navigate winter conditions, it is expensive, slow, and most importantly, a separate device. The average wheelchair user makes around 8 to 20 wheelchair transfers in and out of their wheelchair a day. But this does pose risks such as falls, injuries to upper limbs, and repetitive stress injuries. It is advised that users take their time while doing this process. Overall, it is a time-consuming, complex, and risky and overall difficult task. It should not, for an act as simple and common as going outside in the snow, it should not be this difficult. Which is why our client, Professor Michael Gordon at the University of Toronto, is seeking a design that attaches to his device to reduce the amount of transfers he has to make.
A successful design will carefully balance reusability, portability, and performance. We decided to divide our objectives into 3 main categories: usability, how easy to operate the design; portability, how easy to carry or move the design; and performance, which it will be measured in speed and handleability. So why did we choose these as the top 3? Well, instead of trying to come with a list of requirements, we visualized where our design is going to be used. Well, it's going to be used during winter conditions, so the design is going to get dirty after every use. So it should be easy to clean, and this is where usability is critical. Also, after getting information from client and research and benchmarking with the A40, we decided our design should be portable, meaning it should be lightweight, and it also should be compact and easy to install. And finally, the whole point of our design is to operate the abilities of the Permo Z5, meaning it shouldn't disable or affect previous abilities such as the scissor grip and speed. Instead, it should try to maximize some of them, such as the slope climbing ability.
The Mountain Goat helps PF5 users to navigate the winter conditions. It is able to horizontally move up inclines, attach and detach from the wheelchair. The Mountain Goat consists of an aluminum chassis with rubber tank style treads running along either side. We selected styrene butadiene rubber, or SBR, for the treads specifically for its flexibility out of the temperature. This is critical given Toronto's winters can drop to nearly -22 degrees, with the accumulation of snow building up to 46 centimeters. As we all know, we see a lot of corrosive road salt when we go to school. So this is why the chassis material, aluminum, was chosen not only because it is lightweight, but also for its corrosion resistance element, with an acceptable penetration rate of 0.5 mm. Powering the device are two 1,000 watt electric motors mounted at the front of the set, providing power to propel both the user and wheelchair forward. The wheelchair docks onto the device using an automatic locking mechanism, making attachment and detachment simple and independent. The mountain goat connects to the wheelchair using Bluetooth, allowing the user to directly control the device using the joystick, requiring no additional controller or interface.
Of the designs we generated, the Mountain Goat best allowed the use for winter transversibility of Permobil S5 users through balancing usability, portability, and performance. However, not all three aspects could be maximized at the same time. Some trade-offs were needed. To do this, we determined our top objectives, which were performance, portability, and usability. This was because of discussions with our client, and we determined that performance would be the most impactful for our design functionality.
The mountain goat is easy to use. The ramp is down by default and is able to be retracted by the user. The entire setup process, from getting on the ramp to locking in, requires only the user and zero support personnel. This makes the setup simple and preserves the user's independence. The locking mechanism that we will use is a QLK150 device. It works by the user driving up to the locking mechanism, and it will grasp onto the a bolt mounted on the bottom of the wheelchair, which also supplies the device with power coming from the wheelchair's battery. Finally, the regular inputs of the user are converted via program to the electric motors. This allows for intuitive control. And once paired via Bluetooth, the user is able to control the ramp, locking mechanism, and the device itself via the digital interface on his Permobil F5.
Using the Tracture Axis 40 as our benchmark, we defined a lightweight design to be less than 38 kilograms and a design to have minimum device footprint when less than 1,076 millimeters in width by 1,473 millimeters in length. Since our design is made of aluminum and SBR, we used the density for these materials and performed calculations to determine a mass of 143 kilograms, which makes this design a heavy design. Then, as shown on the screen, are dimensions for the Mountain Goat, which are 1,076 millimeters in width by 1,470 millimeters in length, which means that it meets the device footprint goal. We say that the Mountain Goat has adequate portability since it meets the device footprint, but is not lightweight. Thus, even though it has a heavy mass, this issue is mitigated by its performance.
Our top objective was to maximize the safe incline climbing ability of the device, with a goal of 25 degrees matching the benchmark track axis 40. The rubber tread significantly increased the traction compared to the PF5 standard wheels, and our MOS video, which we will demonstrate later, will show that our device is able to achieve an incline of 25 degrees. And our second objective is to minimize the speed impacts on the PF5. Since the motors provide their own external power, this aspect counteracts the added resistance in the winter terrain. and our resistance calculation shows that the power output can maintain the speed of 12 kilometers per hour.
Now, to evaluate the maximum climbing angle of the mountain goat, we utilize a procedure outlined by the U.S. military, which they use to deploy all of their military vehicles, such as tanks. Now, in this procedure, the vehicle is subjected to angles ranging from 3 to 30 degrees, and it's subjected to a ramp with no added obstacles such as snow. The reason for this is because if the vehicle is able to pass through an angle, then it's considered deployable in all conditions at its achieved angle. Now, for our measure of success, we developed a low-fidelity scaled prototype that is 1/5 of the size of the actual mountain goat. And we used a 12-volt battery as well as supplementary weights in order to simulate the load of the wheelchair. Because we are not dealing with the actual wheelchair during this time of testing, we did not include a docking mechanism. We also developed an adjustable ramp system pictured on the screen above using plywood as well as hinges to allow for smooth transitions between the angles that we will be testing. There is also a red line featured on the adjustable ramp, and that is used as an indicator of a successful climb. If the mountain goat starting at the base is able to ascend and reach that line, it is considered a successful climb. And from our results, we figured out that the device is able to achieve values of 25 degrees, and based on that, it's able to ascend the ramp and has a maximum climbing angle.
So what are the next steps? So we already have a prototype, and we know this very security. So next step is to create a process prototype using the materials described before. Then we will start doing safety testings, and finally we will start doing design optimization in terms of cost and material use.
So to sum up, the mountain goat offers Proto F5 users a better method of traversing winter terrain. Other solutions exist, but they are slow, heavy, and there are many other issues plaguing them. So the mountain goat is easy to use. It is moderately portable, but most of all, it is high performing, which allows for the greatest change to the Proto F5 user's life. So even though there's still testing to be done, the mountain goat will guarantee a future where winter transportation for Proto F5 users is as simple as mount and go. Thank you.